Hi everyone, hope you're doing great. In this video, I'm going to talk about two very important things related to Black Friday Cyber Monday planning. So BFCM obviously is in full swing now, it's less than 2 months away. But so how are you going to actually do forecasting? So you want to understand how much sales you're probably going to have based on historical data and based on whatever you have planned. So how can do that forecasting, that's something that we're going to talk, and there's a little bit of a trick here, and so things get a little tricky, so we're going to talk about the forecasting part, but we're also going to see how you can measure the causal impact of whether or not there was a causal effect of whatever campaigns that you took, and if all of your spend was incremental or not, and to what extent it was. So that is something we can do, and we'll use Google's causal impact package for doing that. So that's a Python package, so we're going to see how you can leverage that to understand the causal impact of that intervention. So let's first start um, with the forecasting part. So this is what we're taking into as as historical data. So we're going to take into account Google cost, spend on the Google channel, and then we're going to take into account also Facebook spend, the branded clicks from Google Search Console, and obviously our target variable is total sales. So what is the impact of these are the variables that we have considered in this analysis. This is based on real data, but you can take into account other control variables as well if you want, anything else that you might find to be of more importance. So this is an account for which these channels are the only ones that are like very prominently active. Anything else is like very small scale, so very unlikely to have any major impact. So this made sense here, like for your case it might be more variables as well. So obviously this is how the data looks like. Now, if I just show you the spends graph, and you will see that the date range that I've chosen for this analysis is suppose September of 2024 to a much longer date range. So what I'm trying to do here is it will be two part, right? I already said the first part of the analysis is where I actually show you the forecasting, and the next part is where I go into the causal impact analysis. So in the first part itself, you'll see that the graph of course is going through this phase here, like where in November of 2024, as you can see that there's a massive spike in the spends also, and then it sort of drops a little bit and goes through its own motions, maybe a little rise here again, because of certain sales period during summer, and then there's a little bit of dip again, and this is where the current situation is, of course, somewhere around say October, right? And then you'll see that the graph kind of looks weird, right? Straight lines and all. So this is basically imputed data, because what's happening is this analysis, for instance, was done like say a week back or so, using a data from week back, historical data from that point on and backwards. Now from then forwards I had to obviously impute data, because that data wasn't available. So if I have to predict what is going to be the or what is going to be the sales of this year's, like 2025's Black Friday and BFCM period, then I obviously need data up to that point as well, which I don't have yet, right? So that's the challenge. So you're forecasting, so you actually have to forecast, in a sense, what is going to be the sales for the remaining of October and for the remaining of November before you actually get to that point of BFCM. So that's the challenge, and BSTM is like say around, you start to do the analysis from around say 24th, so you need data up to around that point. And obviously there are multiple ways of doing that. The simple method that I choose, you can use in multiple scientific imputation techniques, I'm going to talk about them soon, but you can obviously do some manual sort of understanding, like how much we actually see. You can look at the data from past year, you can get an understanding of what your planned budget is this year. You can take simple ratios of those things and just expect that, okay, this is the kind of returns we expect, and this is our goals also, and based on that, this is something that we have chosen here. So this is not a sales, of course, this is what we have chosen as a spend. Okay, so we are not predicting anything, we are just saying that this is the level of spend, and this is daily data. So on a daily basis we have more or less chosen the spends to be very similar for both the channels. As you can see, that's why these graphs look very similar. So they remain very stable for a while in October, and there's of course and up to that point in November, and then at some point in November it kind of spikes in both the channels. But by the way, just to let you know, like the spend levels are actually much lower on Facebook, as you can understand here as well from the graph itself. right? So that is the situation, and then we actually go on to do an analysis. So this is where we do a historical data analysis, and we do a forecast of the kind of sales that we're going to get, and you'll see that the r squared is pretty high. This is of course a mean absolute error, and then we get this graph here. So obviously we do a prediction of the sales around this period. We see that there's also a spike around this period, and the spike is actually much lesser predicted, and that's probably also because of the levels of spend. We probably also have to correlate it to that. Now we actually look at the weekly spends versus spend, total spend. This is how the graph looks like, and then we move on to the correlations. We'll jump into the regression analysis again, but just to give you an example of the kind of correlation that exists between the different variables here. So between Google. So by the way, this sat here is Google saturated. So we did do a small sort of an MMM analysis. So this forecasting was done by some MMM coding, which means that it takes into account adstock effects and saturation effects as well. Okay, so I'm not getting into those details, but that is basically a better way, which is why you will see that the model scores are good, because it tried to extract these things from the distribution itself. So Google saturation and Facebook saturation with respect to, say, your total sales, how these two are actually varying, and you'll see that these two are only moderately correlated, but correlation is not always, as you'll see that it's that. But by the way, Google saturated is actually pretty strongly correlated anyway, but Facebook saturated, as you will see, like the Facebook's value with total sales is actually not very strongly correlated. It's moderately correlated. um, so this is the VIF numbers, and none of these are very high. So VIF basically stands for your multicollinearity. So we want to obviously understand, if there is too much multicollinearity, then it becomes a problem. So these are the predicted values. um, this is the total predicted revenue during the entire Black Friday period. And now what you see in front of you, again, it looks kind of strange. This actually derives directly from the fact that we had the same levels of daily spend, right, that we had for the imputed period, which we don't yet have the value. Like from now until Black Friday, I have to put in the values for spends, right? So that was done manually. That was done sort of, that's also kind of predicted in a sense. So you're using some part of your historical data which is also predicted to predict even further future values. So this is basically your daily sort of data. And just to give a quick background here, like for doing things like MMM usually, or such robust kind of analysis, historical analysis on time series data, it's generally better to take into account weekly data, some sort of aggregation like weekly rather than daily, because that kind of smoothens out noise. Like that's like random daily variations, which you really cannot account for just by any kind of modeling, because that's just pure randomness that exists in nature. So based on that, the weekly prediction was done, and from there we actually did a back calculation into daily level predicted, and that was done like equally. So we split it up equally on a daily basis. To be honest, that doesn't really matter, right? I mean, at the end of the day, you want a total Black Friday sales revenue figure, rather than just, okay, on what day we get how much. That's less important. So this is actually the table where you can see, um, this is the start day of the week, and you'll see that this was the actual sales and this was the predicted, and the residual is the difference between how much was predicted. You'll see there's a fair amount of difference on this particular day, on 17th, on the week starting of the 17th. But that's fine. Even then, though, the MAPE values are not that high. Like it can go up to 20% also. Like people say 2%, 5%, that's very difficult to achieve. But anyway, I mean, it's good to have that kind of number, but in general, that's just one day. You'll see the average is less than 10%, which I think is pretty good. With a decent R squared as well. It's explaining almost 90% of the variance, and has a MAPE, a mean absolute percentage error of less than 10%, only 7.7%, less than 8 also. So this is the number of training weeks and all. And what I did here is, this is what is called a validation technique. So this is cross validation, and I'm basically using a rolling window. So meaning that I'm doing a cross validation by just shifting the date by the week, by a certain amount. And this is basically a way of checking on unseen data, how actually it is performing, and see the, how the actual versus predicted looks like for different windows. So you'll see that it's pretty decent. And the MAPE scores, obviously, as they progress, as they progress in future, usually what happens is the MAPE score becomes better, as is the case here. And you'll see in the early period the MAPE scores were higher. So so what's happening is the number of test weeks simply remains, more or less the same. Obviously, towards the end, we just don't have enough weeks, but you'll see that, during these periods here, for instance, so the number of training weeks. So this is basically the training weeks is basically the number of weeks into the, in the model that it's basically taken into account. So, and this is the number of fold. So 24 folds here out of the total number of weeks. So this is cross validation, a special kind of technique to, and a very important, very common technique, nothing particularly unusual, but this is how you just do. I'm not going into the detail. This is a specific technique. If you're interested, you can research on it, or you can ask questions below, I can discuss. So that's out of sample accuracy testing using cross validation, just to see how much the model is actually fitting, and it's doing a pretty good job. We saw there from there as well. So these are the regression results. There are things which could be better here, like coefficients and p-values, but yeah, this is what we got so far from it. Facebook is not showing very much a promise as an indicator of performance, and like I said, it actually has a much smaller level of spend. Yeah, makes sense actually. So this is the residual plot, and it kind of shows, and it's important that the data points are distributed. So this is basically predicted versus the error, and you'll see that, it's fairly randomly distributed around this line. It could be again better, but this is actually fairly good. Like, the more random this distribution of errors around the predicted, around this straight line, the better it is. So zero is obviously, yeah, zero is obviously the perfect case. So if they all lie on this line, that's yeah. So great. I mean, this is residuals, and this is how they are distributed. And this is, again, just to show you how the Google spend varied, and this is on a weekly basis. And what we actually were trying to do here is create something called, day of the week effect. So a day of the week is a very important kind of seasonality. So this is something that has to be built into the model as well, right? So we want to understand how much spends naturally, rather how much sales naturally vary, just by, just as a sort of an outcome, or sort of as an effect of the day of the week. So suppose naturally for a brand, sales are higher on Tuesdays or Wednesdays, for instance, or maybe on the weekends. So that's what we want to understand, because that is something that's not happening because of any kind of marketing effort. That just happens naturally. Okay, that could be for a number of reasons, but that's something you must have seen very commonly, and I have seen over my span of several, nearly a decade of career in marketing and analytics. So that's very common. So day of the week effect is possible by basically assigning a dummy. So basically it's zeros and ones that we are doing. So if it's, and it's all with respect to Monday, as you can see. So it's from Tuesday to Sunday, so therefore it's all with respect to Monday. So whether or not, so basically what happens is there's something called a dummy variable trap, again something I'll talk about more in the future. You can't include all the dummies, essentially. So if you have transformed it into zeros and ones, you can't make it, you can't take all the variables, because then there's perfect multicollinearity. um, Perfect collinearity. So you drop that Monday variable here. We take the other ones, and with respect to the row, so suppose it's a specific, row of, corresponding to a specific date. Then if it's a Tuesday only, in that case it will be one, otherwise it will be zero. That's how all the, that's how these columns will work. So you'll see this is an example. So for each of these dates here, you'll see that, so what we have done is created this sort of a table. So one point here is that you must have seen that we have suddenly gone from weekly to daily, and this is actually important because causal impact has to be done on a daily basis analysis. It's not very useful to do weekly analysis for causal impact, because that's the kind of analysis that it relies on. It's unlike MMM. Causal impact is usually a localized effect that you're trying to see, right? So it's a local maxima or minima. You're trying to understand whether or not the causal impact happened then. You're not saying that the causal impact is like forever. All right, that's not how it works. Like, there's a lot of arguments around that online. I read them with almost like kind of with amusement or bemusement. I don't know what's the best word, but it's weird to even think that that's how will it will work. Like, interventions, most marketing interventions are for a limited period of time. It may have long term effects. That's a different point of view. This is like whether or not it has an effect now. That's all it's trying to analyze, and that's um, something that will be done on a daily basis. Okay, so unlike the analysis that we just did, which was a more longer term understanding of the relationship, historical relationship among the variables, which will basically be used now, right? So that forecasting we already had, but that's just to give an idea of what is the kind of sales we can get. And once that intervention has been done, so this basically, up to this point, whatever we have done helps you take decisions regarding your marketing campaigns. Okay, and once you've done that, like how much, so based on this you can understand, okay, this is what we've done in the past and this is what we've got. Is that enough? Do we need to do something else? So you take those decisions. Now once you've done that, then you go ahead after that. So suppose after 1st or 2nd December, you start doing the analysis, and then you actually take a post treatment window also, just to be sure of any lingering effects. And then you do an analysis of, okay, whether or not the impact of whatever campaigns we did was causal or not. Okay. By now, if you have seen my channel and videos in my channel, you know that causality is important. Correlation does not imply causation. So this is how this table is going to be built. And you can see that for each of these dates, if it's a pre-period or a post-period, because what we're going to do now is, like, we're going to define that intervention date. And intervention date here is basically when that specific increase in, like, this can be anything, by the way. In this case, it was like several specific campaigns. There were assets that were introduced in Google. There was increase in budget, so it was a set of things that were done together as part of BFCM, optimization, or you can say intervention. So therefore the date has been distributed between pre and post. And the date of intervention is actually 23rd of November. That was the date of intervention. And you can see that it's zeros and ones. So if it's a Wednesday, it's one, and so on and so forth. This is just some lingering analysis after that, but this is the causal impact study now that we can do after this. Again, these two are not necessarily related, but these are sort of chronological in a sense, because you do the forecasting first, you do decide on the basis of that what you will want to do in terms of marketing campaigns, and then you finally, after the marketing campaign has been done, you can go ahead and do a causal impact study. In this case, obviously it's not even November yet when I'm doing this video. Black Friday is still to come. We're still in October. So what I'm going to do is, I'm going to use historical data. I'm just going to do a causal impact analysis of last year's BFCM for this particular brand, for whatever they did on Google. Again, it's a Google heavy brand. And this is the equation, this is the model that we are choosing for causal impact study. We obviously have a basic level and trend. We have some non-paid sessions. This is a good control to have. So we how it works is, like, you need control variables for it. You have a target variable, and you also have your other kinds of control variables. We have non-paid sessions. Non-paid sessions, again, this is something you can get from GFO data. You have Google Search Console data for branded clicks. This is what we use as controls. And we also have the day of the week effect for seasonality. And then we have an error term, and obviously this is our treatment variable here, which is total sales. So this is how it is built. The rest of the code is just for building the data set. So now we are talking about the second part of this analysis, where we are doing the causal impact analysis. And as you can see here, this is the data set that was built, that we just talked about. We have these different control variables, the day of the week effect, and seasonality, which is a binary sort of a construction using dummy variables. And then we obviously have Google and Facebook spend. Now, just to understand here, like, spends by different channels are usually not taken as control variables for causal impact study. And that's because the spends themselves can be impacted by the intervention, and the intervention sometimes are the spends themselves, like, in many ways, like, increase in spend, or you create a new campaign which then also affects the spends. So usually they're not taken as control variables. In this case, of course, we're going to drop Google spend, because that's the direct intervention with sort of, or if not the direct intervention, or that's very directly related to the kind of intervention which of which we are trying to measure the impact of, of which we are trying to measure the impact. Facebook spend, on the other hand, we did not actually increase. We did not actually increase too much. Like we saw from last year, we did increase, but it wasn't very much so important, so very much important rather. So Facebook spend is going to become a control variable in this case. Again, this is something you can do, like you can run the analysis for multiple iterations of it, where you drop one variable, include it, and just see the differences. In my case, it actually did not do too much of a difference, because again the levels were not very high for Facebook spend. It was like less than 1/10, I think, of Google spend. So again, we changed the obviously the value of date column values to date time to fit the analysis. Again, I'm not going into the Python specifics. Just ensure that there were no missing dates. Very important for this kinds of models, because these are like pre-built models, right? So they require the data to come in a certain format. Like this is very similar for Meridian as well. I've talked about this in my videos on Meridian. These are pre-built models, and therefore if you have to use causal impact, you need to provide data in a certain format. It needs to be ready for it. This is how the data looks like. As you can see, this data now I've built it in this way, that for the date, it starts from 5th of August of 2024. Like I said, it's going to be obviously causal impact of last year, like and then the 1st December of 2024. These are the columns that we have now, and there's one column called phase as well. This of course is a string value, and this just says whether it's pre or post. You will see that for non-paid sessions it's actually zero non-null, and that's because from GA4 I could not actually pull the data. Correct me if I'm wrong, but GA4 does not give that kind of old data, or I think in this case, or sorry, that's not the case. What really happened is that for GA4 I did not have access to this date range of data, unfortunately, for this particular brand. So that actually essentially became non-available to us as a control variable. This is the variation of revenue over time, just again plotted. And what we have done then, gone ahead and define an intervention date. Using that, we just split up the graph between two parts here, and then we have an XV line here, and which just gave us the there you go, XV line, and then which gives us that split. So you can see that this is the point of intervention, like around 23rd November that we talked about, and based on that we have the pre and post intervention period, which is given in green, and you'll see that there's a clear jump. But that's just visual inspection. Now we get into the real analysis part, causal impact analysis, where we simply load the causal impact package. This part is so smooth, and it's really awesome. It's going to be pretty quick, and you can see now we just see these columns again, but some of the columns we actually have to drop. So that's why we are dropping all the columns, because it's important. It's not going to understand on its own which columns are supposed to be passed to the model. So you have to drop anything that's redundant. So we actually did, for the purpose of building this graph, for instance, we created a dummy, sort of a, yeah, dummy or duplicate of the target variable, this revenue original one. We're dropping that. We're dropping phase, which not required again in this case. Non-paid sessions, we don't have the data, like I said. And Google spend, like I said, we're not going to use that as a control, because that's the sort of direct intervention related to the intervention. So this is what we're left with then. So we have total sales as a target variable. So this is how it has to be organized. Like date is obviously going to be there. It can be anywhere. It's going to recognize date as the date time column, but it needs to have the very first numeric column has to be the total sales one. The very first, should I say, non date column has to be total sales. That's that, or rather the KPI variable, the target variable. That's how it has to be organized for causal impact. That's how it understands total sales as the target variable. There's no other way to do that. And then the rest have to be your control variables. So that's how it's designed. So this is what we have then as under describe, and then we had just reorganized it and just re-indexed it with the date being the index column here. That's what we have done. And you can see now we simply go into that period, where we do uh, the causal impact analysis. So now we have defined that there is a marketing pre-period, there's a marketing post period, and we use these variables as inputs into this model. So you'll see that it takes into account our reindexed data frame, and then we have this different pre and post periods, and we pass it to the model as arguments, and then we actually print the summary. So the summary is very interesting. It gives you the 95% confidence interval, absolute and relative effects. So it has a relative effect of 79.89% or 80%, which is really great, and it's a positive impact. And you can see that of course it's has a significant absolute impact as well. And so there you go, average and cumulative as well. And the posterior tail probability, this of course is based on Bayesian models, as I've discussed previously in my videos. Like, it's a Bayesian Structural Time Series model, or BSTS, and the probability of a causal effect is 100%, right? And that's because it's the p value is very small, like much lesser than 0.05. So this is how the graph looks like. So this is the original one. As you can see, this is that period again, 23rd of November, where the impact started, and obviously there was a significant spike in total sales after that. I'll see, so this is to understand, like, whether or not there was selection bias, or whether or not there was actually other extraneous variables that actually caused it, so that you understand whether or not it was really the impact of your ad spend and your like very targeted marketing campaigns, or whether it was simply something that would have happened anyway. Is the spike really some because of something that's just counterfactual, like it would have happened, or is it really planned? So you'll see that with the confidence interval, how this point affects. So this is the effects which have been plotted over time, the effect of the campaign, and you can see that clearly it's growing. It's a very nice graph, and that's precisely why the cumulative effect is like almost a monotonically increasing graph. Now, ideally, this is actually the end of the analysis. That's all there is to it. You already have visualized it. You've got the statistical significance and the effect values. You have got pretty much everything. But if you actually do this, like impact summary report, it gives you almost a Gen AI style. This is pre Gen AI, by the way. Much It has been there for much longer before that, and it's a very nice Gen AI kind of an output. It simply gives a textual version of whatever you got here in this part here in the initial report. So that there it actually clearly gives you that what are the results in terms of absolute numbers, and the fact that the positive impact is actually statistically significant and unlikely due to random fluctuations. So very nicely it gives you that output. We also have the errors and the statistical plots to understand whether or not this was just by chance again, or how the errors are looking like. And you can see that all of this is actually pretty good. So the overall diagnostic assessment is that the residuals, as you can see, they're pretty static around this zero line before the intervention, and that makes complete sense, right? And then you can see that so it feeds the baseline very well. Stable pre-intervention, you can see this is centered around zero, the histogram, and therefore that's also shows that there's no major bias here. And the normal the normality assumption has really worked very well. This is called a QQ plot, and this basically gives you whether or not the residuals are also sort of normally distributed. And you can see that the autocorrelation, which just shows you that the ACF plot just shows you whether or not the values were really auto the total sales value, whether or not they were auto regressive in nature. And you can see that there's no significant spikes and no major temporal like very little temporal autocorrelation. So this is where you should not have any major spikes here. So it should gradually reduce, and that's pretty much what's happening here within ACF. So it shows that there's not much autocorrelation. So if you have any further questions, that's pretty much actually that's the overall analysis. And this is how you can basically understand whether or not campaigns had causal impact analysis. There can be other ways of doing it, but this is one of the most popular methods with which you can get things done quickly for causal inference analysis. Thanks for watching. If you have any questions, do let me know in the comments. More than happy to answer them, and I'll see you in the next video. Thanks a lot.